Hey, what is going on, everybody? So today we have a huge video covering why animal agriculture is an absolute joke. We'll primarily be discussing this from an environmental perspective, honing in specifically on its contribution to greenhouse gas emissions, overall land use, water use, the amount of calories we get out of it given its land and water use, proposed alternatives to conventional animal agriculture like grass-fed beef and regenerative animal farming, and lastly we'll touch a little bit on the problem of antibiotic resistance and how it is exacerbated by animal agriculture. I would also like to discuss animal agriculture's impact on global pandemic risk, but if I were to do that, this video would be far too long, so perhaps I'll cover that in a separate video. Something should be made very clear. Whether you agree or disagree with me on the ethical issues I have with animal agriculture, animals being mass-bred, commodified, exploited, and murdered for food, clothing, and other purposes, I would argue that if you care about humans, animal agriculture is a system of food production with many externalities that have the potential of harming humans. As stated earlier, we will be primarily discussing animal agriculture's impact on the environment, plus a little bit on antibiotic resistance. But man, I have to say that as I continued to research for this video, it became more and more clear to me that even if you simply care about humans and not animals, you should still be condemning animal agriculture. And that will be made clear by the end of this video. And lastly, before we begin, videos of this kind are incredibly research intensive to produce. This video specifically has been in the works for many weeks, so if you appreciate this video and my work, please consider supporting on Patreon or even sending a super thanks in the comments. Financial contributions of this kind go a long way in supporting the channel, and if you can't afford to do either but still want to help, understand that liking, commenting, and sharing helps too. Now, on with the video. First, I want to discuss just how inefficient animal agriculture is from a perspective of land use and the global calories we derive from it. Of the 71% of habitable land there is on the planet, 46% is used for agriculture, and of that land, 77% of it is used for animal agriculture. This includes grazing land for animals and arable land used for animal feed production. Now, although we use over 3/4 of our agricultural land for animal agriculture, we only get around 18% of our global calories from it. Is this not just ridiculous? Especially when you compare it to plant agriculture used directly for human consumption, which uses 23% of our agricultural land, or less than 1/4 of it, while supplying us with 82% of our global calories. I mean, these facts alone should tell you just how inefficient animal agriculture is as a global food system. Even from a perspective on protein, 23% of agricultural land used for plant agriculture gets us 63% of our global protein, whereas 77% of our agricultural land used for animal products gets us 37% of our protein. So even when talking about the macronutrient that meat and dairy is supposedly so rich in, animal agriculture still provides much less of it than plant agriculture while using over 3 times the agricultural land. Truly unbelievable. Now, I think it's important that we break down who the top offender is in animal agriculture: cattle farming. According to this source citing FAO data, beef supplies less than 2% of our global calories and less than 5% of our global protein, yet takes up 3/5 of our agricultural land. And while providing so little of our global calories and protein, it is responsible for about 40% of tropical deforestation. Beef also requires around 326 meters squared to provide 1 kilogram of beef, making it one of the most land-intensive animal products there is. Let's now take that 3/5 of agricultural land being used to supply less than 2% of global calories and pretend we lived in a world where all of it came from grass-fed beef. Well, grass-fed beef requires around 80% more land than conventionally grown beef. So instead of 3/5 or 60% of agricultural land being used to supply less than 2% of our calories, we would have to use 108% of our agricultural land to produce less than 2% of our calories. Truly amazing. So if we wanted to get everybody on the carnivore diet in a world where all beef came from purely grass-fed cows, we would only have enough agricultural land to feed the entire world less than 2% of our current global calories that we get from beef. So good. And on top of everything just covered with beef and land use, beef emits the most greenhouse gases out of all other foods per kilogram of product. Again, while apparently providing us with less than 2% of our global calories. Now, let's get back to animal agriculture as a whole, but just know we will be narrowing in once again on cattle farming in a bit. The FAO in 2013 estimated that animal agriculture contributes to around 14.5% of human-induced greenhouse gas emissions. This estimate is derived from a life cycle assessment approach and includes emissions from ruminant enteric fermentation, which is a part of the digestive process in ruminant animals where microbes in the digestive tract, or rumen, decompose and ferment food, which produces methane as a byproduct. The assessment also includes emissions from manure and feed produced for animals in animal agriculture. There are estimates from the IPCC, which say animal agriculture only accounts accounts for 5 to 7% of human emissions, but this is without including emissions related to feed production, land use change, or energy use. So with this in mind, we're going to be focusing on the FAO's 14.5% emission estimate for animal agriculture, considering it accounts for more greenhouse gas emitting properties of animal agriculture. Of the 14.5% of emissions, cattle contribute to 65% of total emissions, while buffaloes and small ruminants contribute another 9 and 7% respectively. So in total, all ruminants account for over 80% of animal agriculture's climate-related impacts. And here's something very interesting. Of that 80% of climate impacts of animal agriculture coming from ruminant animals, 40% of it comes from enteric fermentation in those ruminant animals. Now, remember what I said about cattle farming for beef taking up around 3/5 of our agricultural land while providing us with less than 2% of our global calories? Well, we just learned that on top of that, it's partially responsible for 65% of animal agriculture's greenhouse gas emissions. I say partially because the cattle contributing to 65% of their emissions is from both beef farming and farming for dairy. When researching for this video, I was curious as to whether cattle farming for beef or cattle farming for milk was more responsible for the 65% of emissions from animal agriculture. I tracked down the original source for this 65% claim and found that beef is responsible for 41% of total animal agriculture sector emissions, and milk production is responsible for 20% of animal agriculture emissions. The remaining 4% seems to be caused by emissions allocated to other goods and services such as animal drop power and manure used as fuel. So while cattle collectively contribute to the majority of animal agriculture's greenhouse gas emissions, beef farming alone contributes to around half of animal agriculture's greenhouse gas emissions. And while I couldn't find how many global calories we get from dairy, I did find that dairy provides us with around 10% of our global protein, which makes the emissions from the dairy cattle look even worse. The general trend I've seen with animal agriculture, and especially cattle farming thus far in this video, is that we're using a lot of resources to get very little calories in return and a lot of negative environmental effects in return. This all sounds super efficient. Something I also found interesting was that there is a distinct difference in emission intensity between beef produced from dairy herds and beef produced from specialized beef herds, or cattle specifically raised for beef. The emission intensity of beef from specialized beef herds is almost 4 times as much as the emission intensity from beef produced from dairy herds. And for advocates of grass-fed beef or grazing systems, which the authors of this paper also call grassland-based systems, grazing systems generally have higher emissions than mixed systems. And according to this paper, pasture-based systems, like grass-fed systems, generally emit more greenhouse gas emissions than more intensive systems in which animals are fed grains and concentrates, because in more intensive systems, animals grow and reach slaughter weight very fast, whereas in more pasture-based systems, it takes a longer time for animals to reach slaughter weight, giving animals more time to contribute to greenhouse gas emissions. The authors of this paper say, quote, "Average emissions intensities are particularly high for specialized beef raised in grazing systems in Latin America and the Caribbean due to the land use change emissions related to pasture expansion. The difference in emission intensities between grazing and mixed systems is less pronounced for beef from dairy herds and negligible for milk." So grassland-based systems seem to be worse for emissions than, say, mixed systems, specifically when comparing beef cattle raised in grassland-based systems to beef cattle raised in mixed systems or industrialized systems. So as mentioned earlier, animal agriculture contributes to around 14.5% of human-induced greenhouse gas emissions. Many advocates of grazing systems, which work as alternatives to currently heavily industrialized and grain-fed or mixed models for feeding livestock, speak of the potential carbon sequestration effect of such systems, helping offset some, most, or even all of the carbon emitted by animal farming. If you don't know what carbon sequestration is, here is a good description of it in the context of soil. As plants grow, they draw down carbon from the atmosphere, apportioning some into their roots. Much of this is released back to the atmosphere when plants die and decompose. But if left undisturbed, some of the carbon in their roots and in plant litter, depending on climate and rainfall, the soil microbial community management and many other variables may eventually be incorporated into more stable compounds in the soil, constituting a net removal of carbon from the atmosphere. This is soil carbon sequestration. So the idea coming from certain animal farming advocates is that through specific animal farming techniques, carbon sequestration could help to offset some or even all of the carbon emissions induced or emitted by animal agriculture. Straight from Grazed and Confused on the topic of ruminant animals in such systems, quote, "Ruminants in grazing-only systems emit around 1.32 gigatons of carbon dioxide equivalent, or 20% of the livestock total, a figure that includes supply chain and land use change-related impacts. Since they account for only a fraction of the meat produced globally, supplying about 1 gram of protein per person per day, this means that per unit of protein output, their emissions intensity is very high. Note that since grasslands play a significant role in mixed crop livestock systems too, the contribution of grasslands to human protein supply is higher but difficult to estimate, and complicated by the fact that animals in these systems may also also be fed grains as well as agricultural byproducts. The terrestrial livestock sector, which includes all livestock fed on land, as a whole contributes 27 grams of protein per person per day, while plant sources provide the bulk of human protein intakes today. These are their emissions. The question is, could grazing ruminants also help sequester carbon in soils? And if so, to what extent might this compensate? As the following numbers show, the answer is not much. Global, as opposed to regional or per hectare assessments of sequestration potential through grassland management are actually few and far between, but range from about 0.3 to 0.8 gigatons per year, with the higher end estimate assuming a strong level of ambition. This potential offsets 20 to 60% of emissions from grazing systems, 4 to 11% of total livestock emissions, and between 0.6 and 1.6% of total annual greenhouse gas emissions, to which of course livestock also substantially contribute. There is a whole section in Graze and Confused covering how they got these numbers, trying to estimate the carbon sequestration potential of these grazing systems. I'll have the entire report linked in the description of this video. But put simply, the carbon offset potential of these grazing systems don't seem too substantial. On an ethical front, it is clear that grass-fed and grazing systems appear better than the more intensive kind of animal farming that confines livestock to less land. But environmentally, the downside is the increased land use this requires and the increased emissions, despite the small amounts of carbon sequestration that can occur to help offset carbon emissions. Another example of this is in white oak pastures, which represent what many refer to as regenerative animal farming, where mixed farming of cattle, pigs, and poultry birds, mainly chickens, was compared to the conventional farming of each species. Their grazing methods ended up requiring around 2.5 times more land than conventional meat production. So let's imagine if all of animal agriculture was replaced by this method. As stated before, of the 71% of habitable land on the planet, 46% is used for agriculture. And of that 46% of habitable land used for agriculture, 77% of it is used for animal agriculture, which is around 35% of our habitable land. Now, assuming all 77% of that land is being used for conventional animal agriculture, let's imagine how much land would be required if we replaced all conventional animal agriculture with the regenerative animal agriculture practice at white oak pastures. We would require 2.5 times more land. So instead of using 77% of agricultural land, or 35% of our habitable land, to generate 18% of our global calories, we would have to use 192% of our agricultural land, or 87.5% of our habitable land. I don't think I need to explain the problem here. And here's something that needs to be said about this paper. The 2.5 times more land claim doesn't seem to be accurate because their monogastric animals were mainly fed from off-farm sources, and the land use from these off-farm food sources were not included in their calculations. And while this study claims 2.5 times more land use than conventional animal farming, it's important to understand that this 2.5 is an average taken from the average land used per animal on white oak pastures, straight from sentient media on this subject. However, there is a much larger accounting misdemeanor. The study averages the proportionate share of land according to the net carcass weight of each animal species, as well as egg mass. As such, poultry birds, which made up 43.2% of the carcass weight, were attributed about 43.2% of the use of white oak pasture land. Pigs were attributed about 10.2%, and eggs about 3.5% according to their relative mass. Cattle, sheep, and goats were attributed 42.1%, 0.82%, and 0.15% respectively. But note that the cattle, sheep, and goats mainly consumed plant matter derived from white oak pasture land, while monogastric animals were fed using imported foods. Despite this discrepancy, the study averages the land use amongst all the animals. This is accounting that attributes a much smaller amount of land to ruminants, mainly cattle, while the monogastric animals are used to dilute their impact through creative accounting, masking the true impact of cattle. In reality, the majority of white oak pasture land should be allotted as part of the cattle land footprint, thus up to 2.4 times the land they are currently allotted. Currently, this paper implies that cattle utilizes 2.5 times the land of conventional cattle, the same factor of 2.5 times averaged with the other animals. However, cattle should be considered as using 5 to 6 times the land of conventional cattle meat, while the pigs and poultry birds are allotted the off-farm land actually used to grow their feed. So assuming their 2.5 times land use applies to all animals equally, it isn't practical. But when we dive a little deeper into their calculations, the land use for cattle makes it even more impractical. So what about this whole concept of feeding crops to animals so that we can get a certain portion of their bodies and excretions in the form of calories? Is it efficient? According to this paper from 2013 titled Redefining Agricultural Yields from Tons to People Nourished per Hectare, 36% of the calories produced by the world's crops are being used for animal feed, and only 12% of those feed calories ultimately contribute to the human diet as meat and other animal products. This paper also found that, given the current mix of crop uses, growing food exclusively for direct human consumption, or an entirely vegan world, could, in principle, increase available food calories by as much as 70%, which could feed an additional 4 billion people. One of the reasons making a switch of this kind is important because of projected increases in global crop demands by 2050. This projected increase in global crop demands is partly due to population growth, but an even larger driver is increasing global affluence and the changes that come with said affluence and diet. Put simply, as global income increases, diets typically shift from those containing mostly grains to diets that contain a larger proportion of meat and animal products, all of which are more crop intensive than just eating crops directly. This shift from plant-based diets to more intensive demand for animal products is termed the livestock revolution, and it is estimated approximately 40% of the world's population will undergo this revolution to more animal consumption by the year 2050. In order to meet these demands, global livestock production systems are shifting from using mostly waste products, crop residues, and marginal lands to more industrial systems that require less land and higher value feed crops. In developing countries with high rates of increasing animal product demands, a greater proportion of cereals are being directed to animals. This makes sense considering industrial systems using less overall land and resources. And the projected increase in our population and demand for animal products makes these more industrial and less resource-intensive systems for animal product production more reasonable. And by logical extension, these projected increases in demand make systems like grazing systems or regenerative animal agriculture less reasonable because they take up more land and resources generally. And touching a bit on water use again, but not just with beef, this paper found that the water footprint of any animal product is larger than the water footprint of crop products with equivalent nutritional value. Finally, 29% of the total water footprint of the agricultural sector in the world is related to the production of animal products. 1/3 of the global water footprint of animal production is related to beef cattle. Interestingly, this paper claims that animal farming puts the lowest pressure on freshwater systems when dominantly based on crop residues, waste, and roughages. But we just covered how in order to meet increased demand for animal products, quote, global livestock production systems are shifting from using mostly waste products, crop residues, and marginal lands to more industrial systems that require less land and use higher value feed crops. So although animal farming based on crop residues, roughages, and waste use less water, they overall use more land. It seems as though we're a different kind of screwed either way. Now back to this paper. While efficiencies of feed to edible food conversions have increased over time, the ratio of animal product calories to feed calories is on average still only about 10%. This suggests that using human edible crops to feed animals is an inefficient way to provide calories to humans. So we already know intuitively that feeding crops to animals only to eat them is much less efficient than eating crops directly. But to hear that on average, every 100 calories we feed animals gets us 10 calories back in the form of animal products really just puts this all into perspective. Now, referring back to the 70% increase in global calorie availability we could potentially have by solely growing crops for direct human consumption, the authors of this paper point out something interesting. In this study, we demonstrate that global calorie availability could be increased by as much as 70% by shifting crops away from animal feed and biofuels to human consumption. To put this number of calories in perspective, we investigated the additional calories produced from yield increases alone for maize, wheat, and rice in recent decades, keeping cropland extent constant at 1965 levels. We find the increased number of calories available from shifting crop allocations is approximately equal to the number of calories gained from yield increases for these three crops over the period from 1965 to 2009. The clear conclusion here is that increasing crop production is not the only way to increase global calorie availability. Changing the way we grow and allocate crops is another way to do this. And animal agriculture works in complete opposition to this goal, seeing as it necessarily entails growing crops to feed to animals only to get a fraction of the calories in return in the form of animal products, as opposed to simply growing crops for direct human consumption. And with our population continuing to grow, and the demand for animal products continuing to grow, we really cannot afford to continue with this incredibly inefficient food system. Now, referring back to this paper speaking on the topic of agricultural land expansion to meet incoming demands for animal products, of particular concern is the environmental impact of developing new agricultural land. In the 1980s and 1990s, tropical forests were the source of over 80% of new agricultural land. Given that global population is increasing and diets are changing, the number of people fed per cropland hectare must increase in order to meet the challenges of food security and prevent further cropland expansion into tropical forests. Now, so far in this video, we've covered how animal agriculture, especially cattle farming, seems to be problematic, whether conventionally done or in pasture-based systems, in regard to greenhouse gas emissions, land use, global calorie production, and water use, especially in comparison to plant agriculture used directly for human consumption. We haven't discussed acidification or eutrophication because I don't want this video to be longer than it already is, but these are also issues which animal agriculture exacerbates. Now, as promised at the beginning of this video, we're going to touch slightly on the topic and problem of animal agriculture and antibiotic resistance. If you're unaware of how antibiotic resistance works, straight from the WHO, Antibiotic resistance occurs when bacteria change in response to the use of antibiotics. Bacteria, not humans or animals, become antibiotic resistant. These bacteria may infect humans or animals, and the infections they cause are harder to treat than those caused by non-resistant bacteria. Antibiotic resistance leads to higher medical costs, prolonged hospital stays, and increased mortality. Examples of infections that are harder to treat due to increased antibiotic resistance are pneumonia, tuberculosis, blood poisoning, gonorrhea, and foodborne disease. So how does this connect to animal agriculture? Well, 73% of global antibiotics sold on Earth are used in animals for food. On industrial livestock farms, antibiotics are used prophylactically or prior to infection taking hold. In some countries, they're not only used to prevent and treat diseases in livestock, but also as growth promoters. Animals fed with antibiotics gain weight more quickly. Fortunately, in 2006, a European Union-wide ban of the use of antibiotics as growth promoters took place. Prior to this, some antibiotics in animal feed had been banned for the use of growth promotion, but as of 2006, these last 4 were removed from the EU register of permitted feed additives. Unfortunately, the FDA in the US has much less strictly suggested that using antibiotics to increase rate of weight gain or improve feed efficiency are no longer appropriate for the approved conditions of use for medically important antimicrobial drugs. They don't enforce that farms in the US don't use them for these purposes, they just suggest that they don't. An estimate from this paper suggests that approximately 58% of antibiotics consumed are excreted into the environment, with more than half of them ending up in the soil. Some of the drugs can be broken down quickly, while others can persist for hundreds or even thousands of days. And I'll just be reading straight from George Monbiot's book, Regenerative, Feeding the World Without Devouring the Planet, which, by the way, I strongly recommend. Sources for the following claims will be put in the description of this video. When manure is stored, the bacteria it contains face powerful selective pressures to resist the excreted antibiotics. When it is spread, both the drugs and the microbes selected to survive them meet bacteria in the soil. As I explained in chapter 1, soil bacteria engage in brutal warfare, using antibiotics to repel or destroy their competitors. They have developed what scientists call an intrinsic resistome. This means they are pre-adapted to defend themselves against dangerous new chemicals. When they come into contact with manure, one of 2 things tends to happen. The first is that bacteria with resistance genes proliferate at the expense of those without. The second is that the soil bacteria acquire resistance from manure bacteria. They do this through a remarkable process called horizontal gene transfer, which means that different species of microbe exchange genetic packages. The result is that soil treated with manure quickly become reservoirs for antibiotic resistance. One study found 114 different resistance genes in soil on the North China Plain. These resistance genes can find various ways into other ecosystems in the human food chain. They wash off with the slurry into rivers. They soak into groundwater. They are blown into the air, and they are absorbed by plants. Resistance bacteria or genetic packages, as well as antibiotics, are sucked up by the roots of crop plants and incorporated into the parts we eat. Of the 27 classes of antibiotics used in livestock farming, 20 are also used in human medicine. Among them are some of the most valuable remaining drugs described by doctors as, quote, the last line of defense. The spread of antibiotic resistance through the food chain, according to one scientific paper, quote, may even be greater than hospital transmission. Already, 25,000 people a year are reckoned to die of antibiotic-resistant infections in Europe. They kill hundreds of thousands worldwide. Without antibiotics, modern medicine would scarcely function. Scientists and doctors beg governments to address this crisis, but the use of these drugs on the world's livestock farms is expected to grow by 2/3 in 15 years. Intensive farming threatens human health as well as the health of the living world. I can go on about how antibiotic resistance poses a threat to humans, but I think you get the point. Now, back to the environment. I promise we're almost done. I want to end this video with a quote speaking on the transformative potential of our food system, switching to one without animal agriculture. This quote is from the largest meta-analysis of food systems to date, which covered the environmental impacts of 38,000 farms producing 40 different agricultural goods around the world. It says, quote, moving from current diets to a diet that excludes animal products has transformative potential, reducing food's land use by 3.1 billion hectares, including a 90% reduction in arable land, food's greenhouse gas emissions by 6.6 billion metric tons of CO2 equivalent, which is a 49% reduction, acidification by 50%, eutrophication by 49%, and scarcity-weighted freshwater withdrawals by 19%. For a 2010 reference year, the ranges are based on producing new vegetable proteins with impacts between the 10th and 90th percentile impacts of existing production, which can be found here. Now, the last thing I want to mention before I end this video is that I don't think that plant agriculture is perfect. There are many areas in which it can improve. However, it is not anywhere near as problematic as animal agriculture. All right, guys, that's the end of the video. Again, this video took an insane amount of time to produce and research for, so if you want to support the channel and get early access to content, please consider supporting on Patreon. And if you can't do that, there's also the super chat donation thing you could do in the comments. That also helps as well. If you don't know, I have a book going over most, if not all, of the anti-vegan arguments you can hear online. If you want to get that as well, that'll be linked in the pinned comment. And there are links below for merch and vegan protein powder, which if you buy, also helps support the channel. Thank you so much for watching, everybody, and I'll see you in the next video.
Dude.
Fuck off, I don't want anything to do with you. Don't ever speak to me again. You're a fucking piece of shit.
Even vegans don't get your weird, stupid wannabe sense of irony here. Who's your audience? Nobody gets these dumb jokes. Dude,